In this video, we're going to be solving a trigonometric equation of a quadratic type by rewriting it as a single trigonometric function. So in this example, we have 2 times the sine squared of x plus 3 times the cosine of x minus 3 equals 0. So again, we're going to begin by rewriting the equation so that it only has cosine functions. And this is going to allow us to use our u substitution. So what we're looking at is this sine squared of x that we need to get rid of. So what do we know about that? How can we somehow relate that to the cosine? Well, recall the Pythagorean identity that says that the sine squared of x plus the cosine squared of x equals 1. By subtracting the cosine of x squared from each side, we get the sine squared of x equals 1 minus the cosine squared of x. And we were looking for that sine squared of x. So we can take the 1 minus the cosine squared of x and replace it for the sine squared of x in our problem. So we're going to go ahead and do that now. So notice that we have 2 times 1 minus the cosine squared of x plus 3 times the cosine of x minus 3. From here, we need to distribute our 2. Doing so is going to get us a 2 minus 2 times the cosine squared of x plus 3 cosine x minus 3 equals 0. Notice we now have 2 numbers that can be combined into a like term. So that's going to give us negative 2 times the cosine squared of x plus 3 cosine x minus 1. Now we're able to use our u substitution. So we're going to let u equal the cosine of x. So replacing our cosine of x's with u's is going to give us a negative 2u squared plus 3u minus 1 equals 0. From here, we're ready to factor. So as we go to factor, I'm going to use the Punnett square. If you've watched my videos before, I call this the disco box. So the disco box is where I take the first thing and put it into the first box. And I take the last thing and put it into the last box. So we're going to have a negative 2u squared and our minus 1. Then we'll multiply the negative 2 and the negative 1 together to get a 2. And we're looking for 2 numbers that will multiply to 2 but add to 3. 1 and 2 are the only numbers that will multiply to 2. And when we add those, we get a 3. So perfect. So we're going to put our 2 and our 1 in those spots. And we didn't forget about the u's. Those go into our factor spots. And now we're ready to see what exactly each of our rows and columns have in common. Looking at our first row, we see that there's a 2 in common. But because our leading box was negative, then we're going to pull the negative out with us. Looking at the next row, we see that they each have a 1 in common. Looking at our first column, we see a u in common. And because we already took out that negative with the pink one, with our row, we can leave it out here. And in this column, we see that there is a 1 in common. And this one's going to be a little bit different because in order to get our negative down here, one of our 1's needs to also be negative. And so we're going to go ahead and put that here because negative 2 times a negative 1 will give us the positive 2 that we're looking for in this space. Now we're able to write our factors. So we've got, let's make us some room here. We have negative 2u plus 1 times u minus 1 set equal to 0. And using our 0 product property, we're able to set each of those equal to 0 separately. Then we can solve both sides for our u's. And once we have both of our u's solved for, From there, we're able to use our unit circle. So remember that u is for the cosine of x. So we have the cosine of x equals 1/2, and that the cosine of x equals 1. Recall that the cosine of anything is going to be the x value on our unit circle. So let's begin by searching for the 1/2. So where's the x value of 1/2 on the unit circle? So we have a positive 1/2 here, and then again here. So that's going to give us an answer that x is going to equal pi over 3, and that x is also going to equal 5 pi over 3. Now let's look to see where we have the cosine of x equals a 1. So where is the x value of 1? And we see that that only happens here at 2 pi. So we're going to have x equals 2 pi, which happens to also equal 0 as well. So it's really kind of like two answers. So let's list those each separately. Now, because our original problem did not give us an interval, so if we check that out, we see that there was no interval given, which means that this could happen again and again and again. So that means that we need to add our plus 2n pi to each answer to account for each cycle through. Which is going to give us the following answer. X equals pi over 3 plus 2n pi. X equals 5 pi over 3 plus 2n pi. And then something interesting is happening here. Because really, if we take a look at this, this is just another version of 2 pi right there. So I'm saying, hey, I have a 2 pi, and we're going to add another however many we want, 2n pi's to that. And down here, it's the same idea, that we're just having a 2n pi. So in this situation, these answers kind of become 1, and it just becomes 2n pi. And that's going to be our final answer there, that x equals 2n pi. And so these answers are going to be our final solutions for our equation. And we're now finished.